Hello, in this video, we will look at recursion versus iteration. Recursion is an alternative form of program control. It is essentially repetition without a loop. When you use loops, you specify a loop body. The repetition of the loop body is controlled by the loop control structure. In recursion, the function itself is called repeatedly. A selection statement must be used to control whether to call the function recursively or not. Recursion bears substantial overhead. Each time the program calls a function, the system must allocate memory for all the function's local variables and parameters. This can consume considerable computer memory and requires extra time to manage the additional memory. Recursion is good for the problems that are inherently recursive. Using recursion, you can develop elegant solutions for this kind of problems. But for simple problems, for problems that can be easily solved using iteration, you should just write loops. So because recursion has a lot of overhead, it's not efficient. Early in this chapter, we look at the Fibonacci number problem. We present a recursive solution. And that recursive solution is not efficient at all. It takes a lot of memory because it redundantly calls the same function many times. In the future chapter, we will present an efficient solution for finding Fibonacci numbers. So please note that when you use recursion, often you get this error is run out of memory. So this is causing stack overflow exception. That is because you have a lot of recursive call. It exceeds the stack capacity. Avoid using recursion if you are concerned about your program's performance, but it takes more time because it takes more time and consumes more memory than iteration. In general, recursion is ideally to solve the inherently recursive problems such as tau of Hanoi, directory size, and the Sierpinski triangles. There's one kind of recursion that is called a tail recursion that is always efficient. So we're going to present it in the next video. See you on the next video.